Fourth grade lesson 7.3 is adding fractions using models. So just before we get into how we go about adding fractions, especially as we get into it with the different denominators, we're going to let our brains adjust to adding fractions using models, building on the previous lesson. Let's go. Our essential question is, how can you add fractions with like denominators using models? Unlock the problem says Miss Clark made a loaf of bread. She used 1/8 of the bread, so she cut it into 8 equal pieces, right? For a snack, and 5/8 of the bread for lunch. How much did she use for a snack and for lunch together? 1/8 is 1/8. Boy, that's not a good color. 1/8 size piece of bread. And 5/8 is 5/8 size pieces of bread. So we can use this model where we have a loaf of bread and it is split into 3, 4, 5, 6, 7, 8 equal pieces because 8 equal pieces, 8's our denominator. We're going to shade in one of the 8's, and then we will shade in 5 more. 1, 2, 3, 4, 5. And how much is that all together? It is 1, 2, 3, 4, 5, 6 eighths. 1 plus 5 is 6. So Miss Clark used 6/8 size pieces, or 6/8 of the bread, reduced down. I know it's not asking for it, but just as keeping this in our head, 2 divides into 6 3 times and 2 divides into 8 4 times, so 3/4 of the bread. Okay, another way we can use fraction strips rather than the picture of the loaf of bread. These are always nice and easy because it's always the same shape. Other things are different shapes. This is a little easier for you to make that relationship to. The one strip represents the whole loaf of bread, and then each 1/8 represents 1/8 size. So here is, we'll shade them the same way. 1/8 that was used for a snack, and then our 5/8 for 5 that was used for lunch, for a total of 6/8. How many 1/8 size parts are shaded? 6 of them. Write the sum. 1/8 plus 5/8 is 6/8. So Miss Clark used 6/8 of the bread, reduced again. Divide by 2, divide by 2 to keep it equivalent. 3/4, most reduced form, 3/4. They didn't ask us to do that. I'm just keeping that in your head so we don't forget. They ask us here to explain how the numerator of the sum is related to the fraction strip model. The numerator of the sum is 6, and the fraction strip model is 6 of those unit fractions. Remember from previous lesson, the unit fractions. So that's what I'm going to put here. Okay, so the way I worded it was the numerator is 6 here, and it took 6 unit fractions, 1, 2, 3, 4, 5, 6 of the 1 unit fractions, like the previous lesson, to make 6/8. So that's how I worded that. Explain how the denominator of the sum is related to the fraction strip model. Well, the denominator is 8. We know that it's going to take 8/8 to make the full. And I just worded it, the denominator is 8. That's the pieces it is cut into, 8 total pieces. If I had 8 of all of those 8 pieces, I have the whole loaf. If I don't, then I have a fraction of it. All right, Jacob needs two strips of wood to make masts for a miniature sailboat. One mast will be 3 6-foot long, and the other mast will be 2 6-foot long. He has a strip of wood that is 4 6-foot long. Is the strip of wood long enough to make both masts? Okay, in order to really see what's going on, it really can be helpful to picture this. I mean, maybe some of you can go, oh yeah, yes or no or whatever, but there was a lot of information here. Let's take it one step at a time. Let's do a picture. So we'll start. They did kind of a picture for us. They said, okay, 0 and 1 on the number line. Remember, a number line goes 0, 1, 2, 3, 4. We are zooming in between 0 and 1 because fractions are those in-between whole numbers. And so this is one whole. I'm going to put one whole up here. 6 out of 6 means still the whole thing. And these are the fractions in between. If I cut it into 6 equal pieces between 0 and 1, here is 1/6, here is 2/6, here is 3/6, 4/6, 5/6, and 6/6. They say write the sum because we need one that's 3/6 for one mast and one that's 2/6 for the other one. So how much total do we need? We need 3, 6, and then 2 more 6. So we will shade in 3, 6, 1, 2, 3, and then we will shade in 2 more 6, 1, 2. So we need a total of 5 sixths. Is the sum 5 less than or greater than 4 6? 5 6 less than or greater than 4 6. Well, if we have something cut into 6 equal pieces and we only have 4 of them, that's less than having 5 of them, right? And I can color this a different color. Down here, we only have 4 6 is what they said here. So is that enough to cover all 5 6? No. Is the sum less than or greater than 4 6? It's greater than 4 6. So the strip of wood is not long enough. I need more in order to make both masts. I only have this much, but I needed this much. Explain how you use the number line to determine if the sum was less than 4 6. Well, I compared 4 6 on that number line to the sum of 3 plus 2, 5 6. I guess that's how I'll word that. Here's how I worded it in case you need that. I compared 3 plus 2 equals 5 for 5 6. 3 plus 2 equals 5 6 to 4 6. 4 6 was less. 4 6 was here. 5 6 was there. What if each mast was 2 6-foot long? Could Jacob use the strip of wood then to make both masts? If it was 2 6 long, each of them, we have a 2 6 and a 2 6, and that shaded would be, we'll use a black color, 2 6, and 2 more 6. 2 plus 2 is 4 6, and I have 4 6. So yeah, then there's enough. If he has 4 6 and he needs 4 6, he has exactly enough. There it is. He has exactly enough. Let's look at the Sharon show. Adrian's cat ate 3/5 of a bag of cat treats in September. I'm just going to mark that. If I'm in a book, I can circle that information. If I'm on Think Central, I can just write that information down. So 3/5 in September. And 1/5 of the same bag of treats in October. So 1/5 in October. What part of the bag of cat treats did Adrian's cat eat in both months? So this is no different than when we were doing word problems earlier. What part of the bags of cat treats did Adrian's cat eat in both months? Now the strategy I use if I'm not sure which calculation to do because my brain freezes up is I turn those into really simple numbers. If I'm not sure, like if it doesn't stand out to me, oh, I need to add these together, I change these numbers in my head and say, oh, cat ate 1 bag of treats in September and 2 bags of treats in October. How many bags of treats did the cat eat in both months? And automatically my brain goes, oh, well, that's 3 because I'm not caught up on the difficulty of the numbers. So use that strategy, put simple numbers in there to let your brain figure out, oh, it's that. I just need to calculate with an addition. So if that helps you, there's a strategy I use. Use the model to find the sum, 3/5 plus 1/5. We know we need to add them. 3/5 in September, 1/5 in October. How much is that all together? We need to add those. And we have the model over here. We have the 3/5 that they showed, the unit fraction here, and then 1 more fifth for a total of 4 pieces that are shown. So 3/5 plus 1/5 is 4/5 of a bag. 3 plus 1 is 4. Denominator stays the same because it's still cut into those size pieces. Let's look at the Sharon show. Number 2 says, I have 1 whole. They want us to use a model to find the sum. We're doing 1/4 plus 2/4, 1/4 plus 2/4. They put 1/4 there, and then they put 2 more fourths with it. And so together, there's a total of 3 of the 4, 3/4. How about over here? Here's 1 whole. They cut it into 10 equal pieces, and they want me to add 6/10 plus 3/10. So I have 6/10 modeled here, shaded in, 1, 2, 3, 4, 5, 6, and then 3 more tenths, 1, 2, 3, 6 plus 3 is 9/10. The denominator's not changing because I'm not changing the way I've cut these up. I'm just changing how many of those pieces I have. Denominator stays the same. On these, some of you may not need to, your denominators are all the same, it's cut up the same way. Some of you may not need to model this at all. You can go ahead and pause and fast forward through my models and check your answers. If you need the models, I'm going to model those too, just so that those people who still need it, your brains are still getting the hang of it, can see it. Okay, this one wants 3, 6 plus 3, 6. I drew the 1, and then underneath it, I drew that same full amount split into 6 equal pieces. So I did 5 hash marks here because that gives me 1, 2, 3, 4, 5, 6 segments, sixths. And so there I've written in the unit fraction of the 6 equal pieces. And I'm adding 3 of them. So I will go 1, 2, 3, 3, 6, plus 1, 2, 3 more 6, for a total of all of them 6 sixths. 3 plus 3 is 6. I'm still cut into 6 pieces. 6, 6 is 1 whole, the whole thing. Let's look at the next one. Denominator is 8. I'm going to go ahead and draw the model of that, but you can try and see if you can solve it without the model. There's the model of it. That's 1 whole. I took that 1 whole and split it into 8 equal pieces. That took 1, 2, 3, 4, 5, 6, 7 hashes to make 1, 2, 3, 4, 5, 6, 7, 8 segments. The segments are the eighths. And I labeled them in their unit fraction form. I'm going to use 5 of those eighths. 1, 2, 3, 4, 5. Then I'm going to use 2 more of those eighths. 1, 2, 5, and 2 of those is 7 of those eighths. So 5 eighths plus 2 eighths is 7 eighths. And finally, we have 1/3 plus 1/3. Denominator is the same, cut the same way. You can calculate it and see if you get it right. I'll model it. There it is, modeled, 1 whole, and I split that 1 whole into 3 equal pieces. 2 hash marks gave me 3 segments, 1/3, 1/3, and 1/3. I'm adding 1/3 with 1 more third, and that gave me 2/3. So 1/3 plus 1/3 is 2/3. And there it is. This lesson really is just about putting the pictures into place so your brain knows exactly what's happening. If your brain knows exactly what's happening, then when it comes to having to apply this skill, then it knows how to reverse that. It knows what's going on. And so that's where we're telling our brain. We're helping our brain see what's going on. Seems like you picked this up pretty well.